Imagine a boundary in space so extreme that once you cross it, there is absolutely no way back. Not even light can escape. This mysterious point of no return is known as the event horizon, and it lies at the very edge of a black hole. The event horizon is not a physical surface you can touch. Instead, it is an invisible boundary created by gravity so strong that escape becomes impossible. Outside this boundary, objects can still move freely through space. But once something crosses the event horizon, all possible paths forward lead deeper into the black hole. To understand why this happens, we need to talk about escape velocity. On Earth, escape velocity is the speed needed to break free from gravity. For a black hole, the escape velocity at the event horizon is greater than the speed of light. Since nothing in the universe can travel faster than light, escape becomes impossible. From the perspective of a distant observer, something falling toward a black hole appears to slow down as it approaches the event horizon. Its light becomes increasingly redshifted and faint, seemingly frozen in time. However, from the perspective of the falling object itself, time flows normally. It crosses the event horizon without noticing anything unusual at that exact moment. This leads to one of the most fascinating ideas in physics. Time and space behave very differently near an event horizon. Gravity becomes so intense that it warps space-time itself, bending the rules we experience in everyday life. Despite its terrifying reputation, the event horizon is crucial to modern physics. It plays a key role in theories about quantum mechanics, relativity, and even the nature of information. Questions like whether information is destroyed inside black holes are still debated today. In 2019, scientists captured the first ever image of a black hole shadow, an indirect view of its event horizon. This historic achievement confirmed predictions made by Einstein over a century ago. So, the event horizon is not just the edge of a black hole. It represents a frontier of human knowledge, where our understanding of the universe is pushed to its absolute limits.